In a previous lesson, I talked about how we use the viewports to help us design 3D objects. And there's a reason why we have more than one view, obviously. If it was as simple as building everything in the perspective view, we'd only have one view. But the main purpose here that we're looking at is the orthographic projection views are giving us a true view. And let me give you a demonstration here. You don't have to do any skills with this, but as you build, you're going to have to keep this in mind. Now, if I go, I'm going to draw a box. And in the top view, I draw this box. For a moment, let's ignore this. Let's go into maximize. And we're going to draw this box in the top view. Without being able to see the other views, this view, it tells us what the length and the width of this box is, but we have no idea how high it is or where it's positioned in reference to the teapot. If we go into a realistic view, we'll notice from here that the box is intersecting with the teapot. That's no good. So using only one view is not going to be a good practice here. Now, when we're looking at the multiple views, we can tell here in the front view that the box is not underneath the teapot. And by going into the front view and maximizing that, I can now manipulate this box, and we're going to talk about moving, rotating, and scaling objects later, but I can manipulate this box so that it physically is sitting pretty close to underneath the teapot. So now in the perspective view, that looks good. Now let's imagine for a second here that we only were working in the perspective view. And the reason why I'm showing you this is because the majority of students try to do this. You can create objects in a perspective view. Notice how I'm doing that right now. But like the other view, other single view, we have no control necessarily over where these objects are in 3D space. If you'll notice, I have the ability to move this object. And now I could sit back and say, hey, that looks good. That looks like the teapot is sitting on that teal box. However, when I jump back in, you'll notice that there's actually a gap between the box and the teapot. That's not realistic because a teapot doesn't float. So just because it looks good in the perspective view doesn't necessarily mean that it's actually going to be right. Another way to test this is to sit back here and say, okay, we know there's a gap there, but in the perspective view we don't see that gap. Let's use our orbit tool and orbit around, and there we go. Now we're exposing the flaw in our scene. Why is this important? Well, you're going to learn how to animate virtual cameras that move around the scene. And if you don't model them correctly the first time, as these cameras are moving around the scene, you're going to see large gaps, such as furniture floating off the floor or windows that aren't really inside the window frames. So I just wanted to show that to you as a kind of a what not to do, now that we're familiar with that. And we're going to talk a little bit more now about some of the other ways to start preparing how to create models by using such things as coordinates and whatnot. In lesson M004, we're going to start talking about how a 3D workspace actually works. We hope to be able to get you to recognize the 3D dimensions that define a 3D object, as well as the pivots given on a 3D object. So if you've taken your basic, your algebra classes, you've learned what the Cartesian coordinate system was. And pretty much what that's telling you is that when looking at a 2D grid, the center of that grid is represented by an object called the origin. And that origin here in the grid is defined by the black lines that actually intersect here in all of our perspective and orthographic projection views. Now, I'm going to go ahead and I'm going to hide the circle here or the sphere for a second. And you'll see that the black line represents a 0, point in one axis. What makes 3D different is we actually have three coordinate systems here. We actually have the X, the Y, and then the Z, which is the depth. And we'll be able to place objects within a certain scene using this coordinate system. So I'm going to go ahead. I'm going to unhide my sphere for a second. And when I select an object, which we'll talk a little bit about selecting tools here in a bit, when we select an object, down in the X, Y, Z, you'll see that I have three sets of numbers here. The X is 0.221. I got a -0, which doesn't make sense, and then a Z, which is 0.221. This object is not perfectly centered on the origin. However, I can go in and type in 0, 0, and 0, and now this object is perfectly aligned on the center. Now, if I was talking about maybe, for a moment, I want to move this up 10 units in the Y direction, you'll notice that the object selected has what we call the transform gizmo on it. And the transform gizmo is the device that's going to show us direction, but it's also going to be used for various other manipulation, such as rotation and scale. When you click an object and you go into the move command, an object here will have a Y and an X direction. We don't see the Z because the Z is coming at us. But if I look at the Y, I can come over here where it says Y and type in 10. And you'll notice that it moved in the Y direction 10 spaces. Now over here in the left view, you'll see that it came off this direction. And you're probably like, wait a minute, you typed in Y. The Y is up and down. That's the tricky part about 3D, is depending on how the object was created, its X, Y, and Z could be different. So a lot of times, to help you out with this, we're going to be using really free-form moving, rotating, and scaling of objects. So if I move this up where I actually want it in the front view, so if this was the ground and I'm moving this up, you'll notice down here that it actually moved it in the Z direction of that object. Now I can go and plug in and say, okay, I want it 100. And it goes there. So unfortunately, the transform gizmo, the X, Y, and Z, isn't always going to be accurate to the view you're working in based on how you created the objects. And I want to point that out to you. Okay, so we can change an object's position by physically moving it, or by coming down and keying in the X, the Y, and the Z. This will be important because if you had two objects, such as a, we'll talk about maybe like this box here, and I don't want to go too far into how to actually size this object up, but let's put it at 0, 0, 0. It's perfectly centered on the origin here. And let's say we want to put this sphere sitting right on top of it. Well, using the orthographic view would probably be okay for an introductory course such as this, to come in and physically try to get it as close as you can. However, if you knew the size of this geometry, and you knew, let's say this was this geometry was 1 inch thick. Well, let's say 2 inches thick. We know that from the origin it'd be 1 inch thick. We would then be able to determine that the radius of this sphere maybe is 10. So from the center to the edge is 10. That would mean that if we want this ball to sit perfectly on this box, the center origin of this sphere would have to be 11 units from the grid. 1 inch for the thickness of this plate, and then 10 inches for the radius of this sphere. And you thought you weren't going to be using math in this course. It's very important that you're comfortable with basic algebra and basic geometry, because that's going to be the fundamental building block for the creation of an accurate 3D scene. However, the tools inside 3ds Max will be very helpful to you.